To conduct a confidence interval test on a population mean, knowing the population variance, follow these simple 4 steps described in the following cheat sheet. Step 1. Read carefully the problem statement and extract the statistics, such as the sample population, the sample mean, the population standard deviation, and the confidence level. Make sure that the problem statement states that the sample is normally distributed, or you may check the normality by using the central limit theorem. Step 2. Get the critical value either from the z-table or by using Microsoft's Excel as shown. Step 3. Calculate the margin of error by using the simple formula shown. And finally, Step 4. Write a concluding statement like, "We are 95% confident that the true population mean is between the sample mean minus the margin of error and the sample mean plus the margin of error." Let's do a confidence level example. The problem statement states, exam scores are normally distributed with a population standard deviation of 5.6. A random sample of 40 scores on the exam has an average of 32. Estimate the population mean with 1. 80% confidence, 2. 90% confidence, 3. 98% confidence, and, more importantly, 4. Draw some conclusions. To solve this problem, follow the 4 simple steps. Step 1. Extract the statistics from the recorded data and check normality. Step 2. Get the critical value from the z-distribution table, or by using Microsoft's Excel. The normal table gives a z-score of -1.28 on the lower tail, and because of symmetry, 1.28 on the upper tail. Step 3. Calculate the margin of error given the simple formula and find the lower and upper limits of the confidence interval. Finally, Step 4. Conclude with a statement. We are 80% confident that the population mean score is between 30.87 and 33.13. Question 2. Let's redo the problem with 90% confidence level. Step 1. Record the data or check normality. Step 2. Get the critical value like before to find a z-score of 1.645. Step 3. Find the margin of error and calculate the lower and upper limits of the confidence interval to find mu between 30.54 and 33.46, as shown in the slide. Finally, Step 4. Make a conclusion. We are 90% confident that the population mean score is between 30.54 and 33.46. Following the same method, let's do question 3 having 98% confidence level. Step 1. Check the data and check normality. Step 2. Get the critical value by using the z-table or Microsoft's Excel to find a z-value of 2.33. Step 3. Find the margin of error as shown in this slide. Finally, Step 4. Conclusion. We are 98% confident that the population mean score is between 29.94 and 34.06. In question 4, it gets interesting. Let's put all these results on a table and compare them to draw some conclusions. We can see that as the confidence level increases, the critical value increases, the margin of error also increases, and consequently, the confidence interval becomes wider. Let's work another example. The ratio of the length of the second digit, index finger, to the fourth digit, ring finger, is often referred to as the 2D to 4D ratio and has drawn much attention from behavioral researchers. A study investigated the 2D to 4D ratio within a sample of women of European descent at a university. A sample of 135 women yielded an average 2D to 4D ratio of 0.988. What is a 95% confidence interval for the population mean? Assume that the standard deviation of the population is sigma equals 0.028. Following the cheat sheet provided in the textbook, let's solve this problem. Step 1. Extract the statistics and check normality. In this case, normality is assumed thanks to the large sample. Step 2. Get the critical value. Z-value from the standard normal distribution table. Step 3. Find the margin of error. The 95% confidence interval for the population mean is between 0.983 and 0.993. Finally, the most important step. Step 4. Draw a conclusion. Therefore, we can be 95% confident that the mean 2D to 4D ratio for women of European descent at this university lies within the 0.983 to 0.993 interval. However, this conclusion applies only to the population from which we sampled, and any time our sample is not a random sample from the population of interest, there may be biases present. I hope that you have well understood the confidence interval procedure on a single sample, knowing the population standard deviation, sigma. In the next video, we shall discuss confidence intervals of a population mean having sigma unknown. Check our textbook, Illustrated Statistics for College Students, on Amazon. Details are on the description. Thanks for watching.